Hello, this is AvaniPatidar, a third year student of IIT Bhubaneswar. And for my DSP laboratory course, I was given an assignment to uh, collect the data from a PPG sensor and process it to find the pulse rate of the signal sensed by the sensor. So here we have the first few lines of the code. We describe some constant integer 300, which is the size will be 300 samples will take one time. The float x, y, and FOD give us the arrays which we'll use further in the code to store the data. In the void setup loop, we'll just put our setup code, which is here serial begin 96100, which here 99600 is the baud rate we are using mm, for the operation, and pin mode A1 input, which will make the A1 port of Arduino Duo which we are using Arduino Duo, and pin 2 inputs. This input of A1 is connected to the sensor's S S port, and the plus and minus port of the sensor are connected to plus 5 volt and ground of the Arduino Duo respectively. Then we have this void loop in which we'll put our main code. First we define some integers like peak to store all the peaks, peak I to store the position of these peaks, sys peaks to store the systolic peaks, and distance to store the distance between systolic peaks. Pulse rate is obvious for that. It will store the pulse rate of the samples, 300 samples, and float will float sum is for various operations we'll use during the code. First, this part of the code, it's just taking input from the sensor. We are putting analog read A1, which will read from the port A1 and store the data into xi, ith index of x, and x will be our sample array. Now, for the first part of the processing, we have this MAF, which is moving average filter. Moving average filter is used to um, average the sample. It will smoothen out the sample. It's basically a low pass filter, which will reduce the and eliminate the high frequency components noise. With we are using L is equal to 5 for this MF, which is its order, fifth order. Next we have the this code. This is FOD. FOD is the first order derivative, so it will store. It is basically a high pass filter, and it will store the information about maximas and minimas of the sampled signal X, uh, and its average filter Y. So maximum and minimas will be stored in the FOT, and that's how we'll find our peaks later. Before that, we'll again use MAF of order 15 to smoothen out this FOD filter, so that we can use it for the uh, so we can use it for the detection of peaks. Now for this part of the code is for detection of peaks. We put a int and we put a for loop in which we'll search all the negative zero crossing points, which will be for maxima, and we'll put them into peak. The peak array will be used to store the values of these peaks, and peak I will be stored the indexes or the position of this peak. Sum will use here to sum all the peaks, and count how many peaks we have. The significance of sum and count is that we'll use this average threshold will like sum by count. Average threshold, this will be used to determine between systolic and diastolic peaks. Here's how we'll determine the next part of the code is where we find all the systolic peaks. There's a for loop for the whole array, and then there's a if statement that if the average threshold value is lesser than the peak, any index, so any part of peak array, so that element of peak array will be stored in the sys peak position, will store its position, and in sum will again store the cumulative difference between the consecutive two peaks and count how many differences we have. And in the end, here's we have distance. It will be the average distance between two systolic peaks, like the average sample difference. Here we have the the cumulative difference and divided by count 2 minus 1. The minus 1 here we have is for the first, which this count 2 and count 2 minus 1 will use, because there's no minus 1 figure for the count 2, and will increase our count 2. That's why we'll decrease one count and have the distance between them. The pulse rate can be should be in beats per minute. Therefore we'll divide this distance by 50, which is our sampling frequency, and multiply it by 60 for beats per minute. The will then serial print pulse rate as a text, and then pulse rate float value as the variable. After that, we'll use serial print again in a for loop to print x, FOD, and the MAF values. And here's how we can see the monitor. These are the values the sensor is getting, and here's the pulse rate. Now the and all we are not measured, we couldn't measure correctly because the sensor is misbehaving, but you can see that the code is again. If we see here the plotter, so you can see the waveform, and I'm using my thumb for the pulse, and it's pulse measured from it, but the sensor is misbehaving. So you can see that if we have a better sensor, we can do it just fine. Thank you for your time.